Okay. Hi, I'm Chad Slaughter. Welcome to my talk, Beyond Foreign Data Wrappers, Building a Data Warehouse from Heterogeneous External Data Sources. One of the things I'm not going to, I guess, intro about myself. I've been doing Postgres for a while and done lots of things. I literally have no idea how long I've been doing Postgres, since the 7 series, and for the last few years, actually, we've been working with Hetty in the previous talk on implementing bitemporal support, and then working with several startups on using some of the ideas I'm going to talk about here to solve sort of their data warehouse problems. When I talk about data warehouse problems, it's really about how these companies can effectively pull in complex data from different sources, not only third parties to themselves, but also like their production OLAP database, and be able to build reports for marketing, finance, operations, things like that. So, so the ultimate goal here is to, how do we get the data to everybody as fast as possible? So, and we have Postgres. I assume everyone knows what foreign data wrappers are. Yes? Good, because topic is labeled advanced, so I don't have to explain it. But and I'm not going to go into details installing some of the more complicated ones, though you're free to ask me afterwards how to install some of them. Most of my answers will be install Debian and use one of the packages. They actually work pretty well. So, traditional data pipeline. We usually using a third-party tool, sometimes using Postgres, but ultimately, how do you deal with a situation where you're working at a startup, all you have is Postgres, and you want to give people their data as fast as possible? You don't really need a complex BI tool. You don't need a complex data loading tool. You just need Postgres. All right. So the wonderful thing about foreign data wrappers and Postgres in general is that you can actually do all your ETL right inside Postgres. There isn't any need for any third external tools. And all the startups I've been working with, everyone just has access to either pgadmin or running queries through Excel, or even running pSQL directly to get the reports. So in most cases, it's somebody just wants to do a select on a view to get the information that they want. So we're not having to deal with some complex setup or some sort of pretty report that needs to be delivered. It's people who actually need this data and need to process it, but the data is coming from lots and lots of external sources. Okay. So most people have probably dealt with ETL inside Postgres as well. You do a copy, you create a CSV file, so you copy it into a table, and then you start writing queries or functions to process it, right? So what we're going to talk about is how to kind of skip the part where you actually store all this data locally and just process it to transform it more or less in memory, and get the reports to people without, again, a whole lot of complexity. So anyways, all right, demo time. It's a live demo. This is not recorded. So we want to create a database. Oh, crap. See, I even already screwed up. All right, so there's nothing here, right? So it's not rigged. All right, so with production and most issues with foreign data wrappers, you have to define a whole bunch of stuff, load them into your database. So I'm going to magically load everything, and we'll sort of go over some of the pieces as we go along. Or not, because I forgot to load the rules. See, it's totally live. Okay. So most problems with foreign data wrappers is you define them, And if you're lucky and you're using a database, a foreign data wrapper that's installed, you get lucky and you get your data. So this happens to be pointing to another database on here, but just using the Postgres foreign data wrapper built in, easy enough to connect Postgres. But if you are unlucky enough to need a foreign data wrapper that's not fully defined, so in this case, this one's on Amazon, boom, we get all sorts of errors, which then makes it difficult to, everyone can see that, right? Yeah, okay. Makes it difficult to now test or write complex things like, say, what if I want to create a materialized view on top of this? So I don't want, right, can't do that. So you have to break down and go, well, I can do with data, but, you know, kind of get around the problem. But if I happen to do something like, say, building up a complex, a complex chain of views or functions where one of them happens to be one of these materialized views, of course, oh, we get this error. Great. Now we're back to the same problem again, just in a different way. And of course, if we just try to run this, boom, we get the same error. All right, so this makes actual testing of your code and your functions very difficult if you can't even get all your schemas and functions to even just do a trivial, you know, select and be processed correctly. So what I did was, one of the things I did was I created a foreign data wrapper that you can basically just shim in for your test environment. So if we create a test database, and I'm not so crazy as to use the network, but when we're doing testing, we have a special environment variable CI. Most online continuous integration systems also use this variable too, so you can use this to sort of trigger select behavior. So in my case, we're using this to load in various things. So loading pgtap, but also loading in this dummy handler, which then allows us to do semi-cool things. So now when same database, right, now there's no data. That was the Postgres one. And of course the Amazon one, right? There's no data, but we don't get any errors. So now if I go and I have my choice, right? I can do my materialized view, I can even refresh it, and everything just works as you expect. So now I can actually load, even though there's no data, I can actually still run my tests. All right, I can run my code, I can run my refresh procedures. If you use materialized views, you usually have a script that's running refresh on occasion. You can now test that, even though it's an empty database, you can actually validate that everything is working right up to the point that the data is not there. So one of the things I will point out is that I'm literally using the exact same scripts, right? This is not, oh, I have to write a complex test script and a complex production script. I'm literally using the same scripts here. So and the magic is just driven off, again, the CI environment variable, where I'm loading the special dummy foreign data wrapper code. And because it's a CI environment, I'm assuming that there might be some special needs for CI environments, specifically as it relates to roles. Usually with a CI environment, you're starting with a completely fresh, empty database, usually an empty cluster. The system I like to use is Circle CI. So every time I run my tests, it's actually a brand new Postgres cluster and a brand new Postgres database. So got to make sure the roles are there and so forth. But beyond that, it's checking for the CI environment variable and just passing that along and then running the exact same code And then in this case, we also load pgtap for things I'll show you in a second. Okay, so very simple. Sorry. The magic, show you some code. As part of in order to get this set up, I have some special code that basically deals with a configuration here, where the really great thing about foreign data wrappers in Postgres is that once you've defined the foreign data wrapper, it really has a single function. It's the handler function that needs to be defined. The name of it is actually irrelevant. The name is simply used to connect to the server, and then your foreign tables are then point to the server itself. So the foreign data wrapper layer is the point where we can actually test everything above that in the database is working, and then swap out the handler as we need. So we can have a separate handler, in this case for CI environment, and then a separate one for production. The hard part of this is me finding the right screen, sorry. I actually have written this code, and it'll be online and stuff like that, so if you want to steal it, it's fine. But the trick is this definition here, which is basically using this same data here, where we go through and we say, hey, I have my multi-corn foreign data wrapper. It happens to be an extension, so we can use create extension instead of defining the functions. But then when we're in the CI environment, we want to use this special handler, right? So yeah. So with that, then pages, a couple hundred lines of code later, what's happening is Postgres doesn't really drop extension, doesn't actually work as you would expect, and but basically what this code is doing is it creates the illusion of it creates the properly named foreign data wrapper and then swaps in the handler function. More importantly, it actually handles updates and things like that too. So it's a little more robust than one might expect. So we can go and look here. If we rerun it, so when we run it the first time, it has to build out the foreign data wrappers. But once we run it again, all it's doing is verifying that the foreign data wrappers are what they should be. That error is pgtap. It's not reloadable. I can't figure out how to fix it properly, so apologize. But the point of this code with the foreign data wrapper is then this will allow you to run this, and whatever your test database is, specifically if you're a developer working locally on your local Postgres, this code will basically reset the environment back to the state that it should be, putting the handlers where they should be. But when we go to, let's see here, that sentence said, I want to switch back to production. We see that production is failing because what's actually happening here is it's actually trying to look for that extension that exists and actually load it. And on this box, I don't have the JDBC forward and MySQL FDW installed. So we get an error, and therefore later on they don't show up, and any code that depends on them, of course, would error out. But the other ones, of course, actually do work as designed. So anyways. Okay. So why are we doing all this? Twofold. We also have tests in the system using pgtap. We go through and we can actually run existence tests to make sure structurally the foreign table is there and any views that depend on it are there. And actually, again, you can run any type of normal PG any type of test you want in PGTAP that doesn't depend on specific data, depending on structural things. You also have the advantage that we're not trying to fetch data as well over the network, so your CI environment can be isolated from your production. So, or if you're, one of the issues that we ran into is that we had a third-party vendor who had a production system that we were accessing. It was a SQL Server database, but they didn't have a test version of that. So we could test against the production one, but we couldn't constantly be hitting it. They would basically rate limit us. Production was already hitting it pretty hard, so we were being rate limited. So for the test, we also couldn't just be hitting the production config, and they didn't support a test environment, so forth. So all of these things fit together. Okay. Next piece. So in order to, so now that we can actually test foreign data wrappers, now we have the issue of, all right, I have a third-party service. I want to access the data. How do I actually do that? I need to build these foreign tables, and how do I go about doing that such that I don't die a horrible death by having to write them? So just to show you what they look like, they're this is just a trivial one, right? So it's just like a, just like a normal create table, other than it's create foreign table, has the server and your options and so forth. But when your third party has a tendency to change tables whenever they want, not let you know, or let you know at the last minute, or you have, you know, tables with hundreds of columns, typing this out gets a little repetitive. So the other thing I built was generate foreign tables here, which basically so what this does is it connects to a database. It supports Postgres, MySQL, and SQL Server. It's using Ruby and the underlying built-in Ruby drivers to access the database, reads the catalog, and then creates a underlying foreign table for this. So just to show you, so in this case we're connecting locally to Postgres, so it's easy. But we have two tables here, right? So we're just we just have the URL pointing to it, whatever that is. Again, it can be MySQL or SQL Server. And then it just goes through and creates a mirror of creates a mirror for loading into your foreign table. So when we connect here to example, and because if you're like me, you never remember what the particular data types are. This one's easy because it's Postgres, so it's just a one-to-one data type matching, but in a lot of cases, the data type on the other end doesn't have a meaningful Postgres data type, so the code defaults usually to text. So in all cases, it's once given a table, it will create a foreign table that will connect back to the server in question and be able to pull the data. Basically, if you declare everything as text, everything will end up getting converted to something and can be displayed. In a lot of cases, the values can be mapped, where this is. Most people in Postgres know this. MySQL's date type, of course, is retarded. So the date has to be mapped to text, and then at that point, you have to deal with converting 000 into null for Postgres, and then it can be converted to an actual date type. as an example. But there isn't always a clear mapping. And in some cases, the tool tries to guess, but in all cases, it creates comments so you can actually, inside Postgres, do all your development because you can actually see what is the data type on the other side. So even if the local type is just text, you always know what the source type actually is, right? Source type being defined by, of course, the server that this is pointing to, of course. So okay, so that's one piece. So when we were running this earlier, all I was doing is going through and running this trivial load into the system, right? So what I did in order to make life easier, I use a common structure. Can everybody see that? I don't know if that's big enough. Apologize. Basically, when dealing with foreign tables, I always use the same structure. I create a separate schema for every foreign data wrapper. Effectively, this schema can be thought of as like, here's where all the pieces related to this foreign table is going to be mapped into. This becomes much more relevant when, if you're dealing with stuff that's simple like SQL Server or MySQL, where most of the applications don't use schemas. You can basically just have one global schema per server, but if you are actually using it to access something like Postgres, where you might end up having multiple name conflicts, or the fact that there are schemas in the other database, meaning you can't just dump all the tables into a single schema. So it becomes necessary to start limiting, to start only generating foreign tables for each of the remote schemas and stuff like that. The tool supports that, but I'm not going to go into the details on that. But you do have to worry about the name mapping features. But all we're doing here, again, is going through and trivially defining a server, a user mapping, granting access to the server, and then loading here the file that we just generated, right? So why is this important? Well, the reason why in my abstract I sort of mentioned software development is that what I want to know is what is different about the system in question. So if we go to our remote database and we have two tables, and I'm just going to load a second table real quick. So now we have another example. Then what I want to do is, because my database changed, how do I know this? The vendor got around to telling me that, hey, something changed. So I'm just going to rerun my generate code, and hopefully this will work. Okay. So now the variable points to the file. Sorry. Right. So it's just the same file here. So now with the generate function, I can now do a diff, and I can actually see what's actually changed. This is a horrible diff, but we can see that, oh, there's actually a new table involved. Sorry. My bad. There's a feature I was going to show you in a second. Hold on. That's cleaner, right? So we've now done our generated our code, generated new, and now we do a diff, and we see, oh, there's actually only one additional table now. And so now we can load that into our system as well. Boom. Okay. Yeah. sorry. But now we want to see, oh, well, what's, what actually changed? We see that everything loaded, but now we're actually getting an error from our tests, right? And we actually see that, sorry, we actually see that it's failing because it's identified that there's actually an extra test or an extra table inside the resulting schema, right? So the point that I want to point out that the underlying reason for really demonstrating this in the first place is that how do we find errors faster while and speeding up database development all at the same time? And so the reason I created these scripts and the output is such that they are is so that we can find problems and identify what's actually changed in the system before it gets to production, before things actually start breaking, and that at each step, when something changes, we are alerted that, hey, something changed, and you should take a look at it, right? And in this case, it's expected, right? We added it to the foreign table script, so of course the test failed, so I need to update the tests so that they succeed, and then can move on to production. Okay. What do I do next? So, foreign data wrappers are kind of slow in the sense that when you query them, depending upon the capabilities of the particular foreign data wrapper, you might have to effectively copy the entire table over to your server for every single query. So even if you have a where clause, some of the foreign data wrappers don't push down the where clause stuff or don't push down limit. The Postgres one is fairly robust. The MySQL one is fairly robust as well from Enterprise DB, but other ones, the SQL Server one or the JDBC foreign data wrapper for SQL Server is not so robust. So we now have a problem of we've made it trivial to access the data in the third-party system, but every time we want to run a query, it ends up having to effectively copy all the data back and forth. So how do we solve that? Well, we solve it by basically adding a switch to this command. And what this does is it generates a materialized view for each of the foreign tables. So the structure is third party on your Postgres database, you then have a foreign table pointing to wherever, and then you have a materialized view that's set up to select from that foreign table. So now I do a refresh of all my materialized views. I now have a copy of all my data, and now I can actually proceed to process the data locally without having to incur the overhead of copying the data back and forth for every single query. So actually, let me do something else here. Okay. So what's happening here is we're still creating the foreign table, but at the same time we're prefixing it with an underscore because this is all being created in the same schema, and then we want to create the materialized view with the name of that remote table. So, and then the materialized view is just trivially, right, select star from the appropriate. So, we're still in the test database, so we're using the dummy handler, but all right, so if we select from PGM examples, right, you get, oh, can't because it's a refresh. But if we look at the entire setup, right, we have a series of materialized views and a series of the foreign tables, right? So we can actually, yay. And if we move back to production, we can actually load in that data with the materialized view. So it's just a local data, but I don't think anybody cares. Okay. So, all right, extension, config, right. I'll show you this. All right, go back to the presentation. Okay. Right, the show the code if they're switching. One of the reasons why I'm actually doing this is one of the things about type theory tells us that we don't actually have to look at the data. We can actually look at the type and we can actually infer correctness. So the point of the dummy handler is that if we have a report that's represented as a view in the system where the type is numeric, and we have raw data that's represented by a foreign table that's represented as text, then somewhere in between that view and the foreign table, there must in fact be some sort of cast to the appropriate type. Postgres can actually validate that this is happening and this is true. So even without the data being there, and even without the data, or even without knowing exactly what the data is, we can actually still validate that, hey, we're getting this text in, we're processing it correctly from a type perspective because it's turning into the type that we expect. And then if we go through, we change the underlying foreign tables or we change the views to expect a different type, by actually doing this process of loading the database, even though we're using, and all the foreign tables, using the dummy driver, we can actually validate that our code is mostly correct, at least from a type perspective. So what I've personally found, and at each of these companies that have done this, that when dealing with third-party data, right? So you're dealing with the data warehouse, you're dealing with third-party data, so you assume that the data is going to be crap, right? You know that it's crap. So what you then have to do is you then have to go, okay, have I put in place the proper mechanisms, the functions, the casts, the cleanups that I need in order to process this data? And how do I do that, right? Well, I can actually do it structurally. I can do it just based on types. I don't actually need to see their data. And in this case, what we're building is, we're basically building a reloadable data mart or a proxy to the underlying third-party data that allows us to be completely reloadable, process the data each time we make a change. So this isn't necessarily a structure for terabytes of data, but it works pretty well for tens and hundreds of gigabytes of data to be processed daily and stuff like that. So, right, we want user to have that stuff like so. The dummy foreign data wrapper is available. So is the generate foreign tables. Like I said, it supports MySQL and SQL Server. For Henrietta, like if you actually have to deal with MySQL, I will say there is one additional flag that's kind of hidden in there that actually automatically handles the date issue. So there's a flag that allows you to switch, have it deal with the date, but it ends up doing what I described, which is it creates a foreign table with a text field and then automatically creates a view or a materialized view on top of that foreign table and then does the conversion of the date for you, which basically is it checks for 000, turns it to null, and then casts the remaining text values into the date type or timestamp type as necessary. So my one, my one hidden fix in there. Let's see what else. Yep. Yeah, I use PGTap extensively. So how many people use PGTap to write their unit tests for their data warehouse? Anybody? Good. It's excellent. You should use PGTap. Thank you. Is it a question or? No, you can. Okay. Yeah. So PGTap is not mine. Um, David Wheeler made it. It's a great tool, has great documentation. Um, what I cannot speak highly enough of it. What's really nice about it is it basically has a structure like this. You basically do a begin, you set a plan which has the number of tests you want to run, and then this is set up to do existence tests here where basically it checks like, oh, do I have the schemas I need? Are the owners correct? Are there foreign tables? Or if they're a regular, like in this database case, it's there's only foreign tables, but if there are regular tables or views or materialized views, you can write functions to check them, right? So you now have a mechanism to check that the structure of your data warehouse is as expected, right? It also works for functions. Yeah, I think every single object in Postgres, there is some sort of existence test that you can write for it. So the upside is this all runs in a transaction. You do have to load PGTap, but in a test database, again, you can actually validate that everything that you expect to be there is actually there. So, you know, if you happen to be like me and happen to, you know, do a drop view and like this isn't there, and so you want to force a cascade, and it turns out there was something else that was depending on the view that you didn't expect. This is the perfect setup because now I have a test that can actually validate that I didn't inadvertently delete from the structure a view that I needed, right? And I'm not talking about from a perspective of production or release. It's from just a development perspective where I'm sitting at the console and I'm working, and a view's in my way, or I'm recreating it real quick before I fully write up everything. I can quickly run PGTap and see, oh wait, what actually happened? I dropped something. Oh wait, something's broken now. What is it? Well, now I have all the tests which actually say, here's these things. It also goes further. So for every table, I then create, it checks for the existence of the table, and then also checks keys in the columns and stuff like that, and checks for default values. So you more or less can enforce the structure. What's nice about this is that when the test runs, you are validating against, here's the structure that I expect, right? You are in effect diffing your database. So, so it has those, and then the nice thing, and I don't have an example for you. Sorry about this one. Where's a good example? I will show you in our wonderful PG by temporal stuff. So you can actually write, if you ever used unit tests in Java or Ruby, similar ones exist. So you can use is here. So this is a function, and it's just checking that the value is expected. The other really nice thing is this live's okay, which allows you to basically execute arbitrary SQL code, and then basically it'll check that the code executed or not. And then, because all this is running the same transaction, I can now do more extensive bag equals, for example. You guys probably can't actually see that, can you? I created something above, and then I'm using this bag equality to actually validate that the results coming back from the select are as I expect them to be. There's also result equality, so you can actually check for order as well. And the nice thing about these functions, these are just PGTap functions that need to be loaded. This is all just flat SQL, so you can actually interlace random queries as well. I like to wrap everything in this function so that anything that I expect to run does run. If it doesn't, we get an error, but yeah, if you're not using it, you should definitely check it out. And yeah. So yeah, there's one other thing I was going to talk about, but I don't think I have time. I don't know. Any other questions? Things I didn't cover or I blew over too fast? So. Mm-hmm. Yep. Yeah. So as of 9.6, very little other than, in my view, the foreign data wrapper is easier to define and set up than dblink. So like that would be the easiest. That would be my reason. So I have a script to generate them. So I point it to a database and kick out the config file. So yeah, like I mean, yeah, you can still use dblink, but the foreign data wrapper is in lieu of that. There used to be subtle differences, but in newer versions, there more or less is there is no difference, and so the built-in Postgres foreign data wrapper, again, behind the foreign table, right? So it's basically hiding the access, where dblink, it's a little more exposed on accessing. So the foreign tables are more SQL friendly is really the big difference. So the answer is either. So in one instance, we were creating the foreign data wrappers and the materialized views inside the actual data warehouse, and we're simply rebuilding. We would refresh the materialized views and then ran a series of views and additional materialized views. So it was foreign data wrapper, materialized view, view, materialized view, 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 materialized view. I think it was like 9 deep in complexity. And then another setup, we actually run, we don't run materialized views, we run all of this in a basically sort of creating Postgres as a proxy mode. So the setup is SQL, MySQL, third-party databases. This proxy server, which is Postgres, it has all the foreign data wrappers in it. It has all the foreign table definitions. Then a second database, which is Postgres, using Postgres foreign data wrapper to access the proxy. And so all of these things are exposed through this proxy now as Postgres. So now we can actually use Postgres foreign data wrapper to then access all of these things. The specific use case was Amazon Postgres RDS has the Postgres foreign data wrapper, but it has no ability to load any other foreign data wrapper. So we created this proxy where we loaded, it was just a EC2 instance that had the setup for SQL Server, MySQL, and some other things. So we were actually doing sort of 2 levels of the foreign data, the foreign tables, and then on the production side is where materialized views were being created and stored.
So I'm assuming that you refresh that view every day.
Yeah.
Multiple times, as
Or
often as I need.
more often.
No, but like every 2 hours, every hour, every couple of hours.
If the thing is kind of huge,
Yeah, if the tables are huge, we actually switch to incremental refreshes, but a separate story. It's totally beyond the data
Yeah.
wrapper.
So in most cases, like I said, this is for smaller tables or for smaller databases where the refresh doesn't take. In the first application, if I remember correctly, we had about 280 foreign tables, and there was only one of the tables that was actually problematic, but the entire refresh took about an hour to run. Again, the nice thing about materialized views is we could actually run this refresh concurrently with queries running. The biggest challenge that we found was because of this multi-nested structure where we had materialized views depending upon them on each other, we had to write a it was just a recursive select query on the what is it, PG map views in the catalog to create a list of all the dependencies between them, and then we basically then tiered them. So basically we know like, oh, we can actually run, these 100 materialized views, we can run these refreshes in parallel, and then this next 50 need to depend on those, so we need to actually wait till they're all done and then run the next set. So, and then once we had that dependency, then it was a relatively simple using GNU parallel script to then basically use the recursive query to divvy up the work and then hand it off to a parallel script to then run through and basically do all the refreshes in parallel. So, and then because the data volume, again, we know tens of gigabytes, it wasn't anything massive, so we're able to do that. If I remember correctly, the schedule was like once every 8 hours, once every 6 hours, something like that. So, and then it took, I think, it took like 2 hours to complete, I think, if I remember correctly. So, but yep.
So I run into using the data wrapper, it's a huge table. It's like you say, actually gets all the data,
Mm-hmm.
and the filter is actually executed in the target database or target class. So if that target class doesn't have too much memory, it can actually.
Yeah, then it will go to the disk. Like this is the underlying.
What I have, actually, I don't know if you do the same thing, or just trying to, because I'm running some of the issues with that huge table. That table is about 700 gigs.
Mm-hmm.
And so what I'm using right now is a wrapper with a little a function
Mm-hmm.
that actually go through account whatever I wanted to that huge table.
Mm-hmm.
I'm using do the link. But I don't know if it's the best solution that I'm doing.
So when it comes to lard tables, like I said, it's the solution depends on which foreign data wrapper you're using. So if you're using something like SQL Server, then the recommendation is I would put a materialized view in front of it and then simply refresh the view and basically copy everything over. If you're using something like the Postgres foreign data wrapper, you can actually, I would use a where clause to actually limit the data that you're selecting from the source database, and the Postgres foreign data wrapper will push down the where clause, so you'll only select the segment that you need, the portion of data. The MySQL might work as well. So, okay, all right. Thank you. Oh, sorry.
Not sure how much do you use this S3?
Yes, one of our foreign data wrappers is using S3. Yeah.
So S3, how many files can command?
As many tables as you want. So, I mean, like each. So it depends on the system. The one that I was using, which was S3 access through Multicorn, was basically one file, one bucket and one file per foreign table. So.
But can we say 1 million files in one bucket map to this foreign data wrapper?
Yes, but you would need 1 million foreign tables.
Million foreign. So each
Yeah.
file needs 1 foreign table.
Yeah. So at least the one we were using, there might be a better one that I'm not aware of, but sorry.
Can you create index?
No. The upside to the materialized view then is that you can create indexes on the materialized view, and that's how. So if you have a significant amount of data, that's why I built the sort of materialized view interface, is that you can then suck in that data to your local database, build any indexes that you need to complete your processing.
So it doesn't support the regular oppression like from something.
No. No. So, all right. Thank you.